Alright, so in this video, I'm going to be solving the equation 1 to the power of x squared over 8 to the power of x is equal to 61. So, to solve this, let's first just focus on our numerator on our left-hand side here, 1 to the power of x squared. Well, 1 to the power of anything is just equal to 1. You can do 1 to the power of 100 is equal to 1. 1 to the power of 3 is equal to 1. 1 to the power of negative 5 is equal to 1. Even 1 to the power of infinity is equal to 1. So, it doesn't matter what value x is, this value right here, our numerator, is going to be equal to 1. So, this turns into 1 over 8 to the power of x is equal to 61. Now, this is the same thing as 1 over 8 to the power of x is equal to 61 over 1. So this is a proportion right here. And what I'm going to do is first multiply both sides by 8 to the power of x. So then these two cancel out, and I get 1 is equal to 61 times 8 to the power of x over 1, which is just 61 to the times 8 to the power of x. And now I'm going to divide both sides by 61. So these two cancel out, and I get 1 over 61 is equal to 8 to the power of x. Let me just switch the sides of these, so I get 8 to the power of x is equal to 1 over 61, which is much more simpler to solve. Now, from this point, we want to find a way to simplify both sides. Well, for my left-hand side, I can still simplify 8. 8 is the same thing as 2 to the power of 3. So I'm going to substitute in 2 to the power of 3 for 8. So I get 2 to the power of 3 to the power of x is equal to 1 over 61. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So I get 2 to the power of 3x is equal to 1 over 61. Now, how am I going to simplify this even more? Well, we can't do this with normal algebra, but what we can use is logarithms. So I'm going to take the log on both sides. So I get log 2 to the power of 3x is equal to log of 1 over 61. And if I have something in the form log a to the power of b, this is a property of logarithms, by the way, that you should be aware of, I can move b to the front. So this is equal to b times log a. So in this case, I have log 2 to the power of 3x, and I can move 3x to the front. So now I get 3x times log 2 is equal to log of 1 over 61. Now, we obviously want to isolate x, but before that, we want to simplify this a little, log 1 over 61. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log of 1 over 61 is equal to log of 1 minus log of 61. And now we can isolate x by dividing both sides by 3 times log 2. So these two cancel out, and I get x is equal to log of 1 minus log of 61 over 3 times log 2. Now, if you already know, log of 1 is equal to 0. So I get x is equal to 0 minus log 61 over 3 times log 2. And log of 61, you can use a calculator to find the value of this, but this is equal to 1.7853. And log of 2, which is the other logarithm that's involved over here, is equal to 0.9031. So now I get x is equal to negative 1.7853 over 3 times 0.9031. And this is equal to negative 1.9769. So this is the solution to my equation. And now we're going to do a very important step. We're actually going to be checking if this is right. So let's go back to our original equation, which was 1 to the power of x squared over 8 to the power of x is equal to 61. So this was our original equation. And our solution is right here, negative 1.9769. So I'm going to actually go ahead and plug the solution in here. So I get 1 to the power of negative 1.9769 to the power of 2 over 8 to the power of negative 1.9769 is equal to 61. Now remember, like I said, 1 to the power of anything is itself. So now I just get 1 over 8 to the power of negative 1.9769 is equal to 61, which is the same thing as 8 to the power of 1.9769, because 1 over a is equal to a to the power of negative 1. So 1 over a to the power of n is equal to a to the power of negative n. Now, if you plug in 8 to the power of 1.9769 in your calculator, that's going to be approximately 61. So I get 61 is equal to 61, and this is right, so I know my solution is right.